In the second part of our 1.2 notes, we're going to be dealing with describing where a function is increasing and decreasing, and we're going to define something called the extrema, which are often also known as the maximums and the minimums of the graph. I will point out that for most of these things, we focus on the x values for where things are happening and not the y values. So here we have our definition of when a graph is increasing or decreasing. Basically, you look at the shape of the graph line itself, and you read it from the left side to the right side. And you imagine tracing along it. If your finger is getting higher as you go along, then we say it is increasing in that section. If you find a section where your finger is moving down as you follow it from the left side to the right side, then we call it decreasing. If you're tracing the line from left to right, and it doesn't seem to be moving in either direction for a while, then we call it constant. Most graphs will actually have a combination of these things happening in it. So you'll define for certain x values, it's increasing in this area, decreasing in this area, and constant in this other area. The extrema, or the maximums and minimums, are closely related to this concept, because a maximum is where you hit a high point in a graph, which occurs when a graph shifts from increasing to decreasing, because that has to be a high point if it stopped going up and then it started going down. A minimum would be a low point you see on the graph, or a trough, where the graph has shifted from decreasing and then turned around and started increasing instead. So they may ask you to describe those by the coordinate, or they may just say what is the x value that those things happen at. Here's a nice little example showing that a graph often combines multiple of these intervals. So the first part, we're going to identify where all is the function increasing. So just start from the left and go along the line. Right now it's getting lower. Then it stops and it starts moving up. So it started moving up at an x value of -5, and it keeps going up from this x value until I get to this location, which is x equals -3. So that's where it stops getting higher. And then it seems to be leveled off for a while, and then it starts going up yet again. So starting from x equals -1 until I hit an x value of +1, we have more increasing. And then it starts going down, and then here it's going up again. So starting from this x value of +4 until x equals 5. So this one actually had 3 intervals for where the graph was getting higher as you read it from left to right. Now let's see if we can identify the decreasing intervals. Well, I see one here in the first section, and it started off doing this off to the side of the graph, so my starting point is actually going to be -infinity for that. It looks like it was always doing this on the left-hand side of the graph, and it keeps doing it until we hit this x value right here, which is our -5 value. Then it moved up for a while, then it was constant, then it was moving up again. Here's our next decreasing interval. So starting from x equals 1 on the x-axis, and it continues until we hit an x value of 4. So there are 2 locations where my graph was getting lower as I read it from left to right. And then the constant intervals are where the graph seems to be completely level. So it starts at this x value of -3, and it continues towards this x value of -1. And then I see another one all the way out here on the end, which started at x equals 5. And then it appears to be doing that forever, because this arrow is just showing it goes to the right. So it must be going till infinity. So now we have defined lots of different intervals where the graph was getting higher, lower, or it was leveled off. Now the next part of the directions asked us to identify the maximums and minimums of the graphs. So you want to look for where the graph has switched from decreasing to increasing, or the other way around. So for example, here is a low point of the graph. This is the location of a minimum. we have a maximum up here at this high point of the graph. And then if we continue along, here's another place where it switched from decreasing to increasing. So we would also call this one a minimum. You may be asked to specify the actual ordered pair, like this would be -5. It's probably about -5, -2, but our y-axis isn't marked for us to be precise about the y value. Our second point here, this maximum looks like it's at 1, and then that's probably 1.3 or 1.4. Again, without tick marks on here, we can't be that precise, but some questions may have that marked off so that you can state the location better. So for this, since they only wanted the x values, I'm just going to specify x equals -5, x equals 1, and another one at 4. Here's another example asking us for the intervals where the function is increasing, decreasing, and constant, and to again give the x values of where the maximums and minimums occur. They didn't provide us with the graph on this one, so don't forget that you might want to use the Desmos graphing calculator to draw the shape and then use that for reference. So here you can see that I've typed that equation, y equals x minus 2 squared, into desmos.com/calculator. And when I'm listing out the different intervals, I can see that it was decreasing on the left-hand side until it hit an x value of +2. So I would say decreasing from -infinity to 2 for the x's. For an increasing value, that's what starts at 2, and then it continues for the rest of the graph. So it's increasing from 2 to infinity. And there aren't any intervals where this graph is constant, so you wouldn't need to enter an answer. You would say no solution, something to that effect. As far as stating the maximums and minimums, for the maximum, there is none, because I don't have a location where the graph switched from increasing to decreasing. I have the opposite. I have a low point in the graph, or a trough in it. So I would say that the minimum occurs at x equals 2. So this, sometimes they might use like the at symbol to say it's at x equals 2. There's actually a specific coordinate. I can even say that it's at 2, 0 if I wanted, but a lot of the questions seem to just be specifying the x value only. So that's all for these notes. That should pretty thoroughly cover everything you'll see in both the textbook and the math lab assignments, and I hope this will be useful for you guys.